Good day, everyone. Today we're going to be looking at bipolar junction transistor, the BJT. What we are focusing in today's video is just some relationship and some knowledge that we need to be able to solve, if not all, some questions associated with BJT. So without out of the way, let us begin. First, let's start with what I call the current relationship. Our BJT transistor, to be specific, an NPN, normally has 3 terminals: your collector, your base, and your emitter. Now, each of these terminal has a current that is actually flowing through it. For our collector, which is our C, we have our IC, which we call the collector current. For our B, we have our IB, which we call the base current. And for finally our E, we have our emitter current. Now, from the diagram, our Kirchhoff current law says whatever current that is entering into a node, whatever amount of current entering into a node, it will be equal to the amount of current leaving the node. So if that is so, with the direction of our diagram, we can say the following using KCL, Kirchhoff current law. We can say, looking at the diagram, looking at the direction of our arrow, we can say that IE, or better still, IC plus IB is equal to E. Our IE is leaving this region, our IE is leaving the circle region, but our IC and IB are entering inside it. So hence this expression. Now, you can write this to be this: IE is equal to IC plus IB. Nothing has changed. We just write the expression. We wrote the expression. Now, this is our current relationship. This is how our current are related in our BJT. Now, another thing I also like to add to this, and to also come in handy, is this. We say smaller, smallest. Now, this is a way of reminding us the values and the manner our current is meant to be. Our emitter current, which is our IE, is normally measured in microampere. So this is a small value of current. So hence the name small. For the smaller, which is our IC, it is also measured in microampere, but it is smaller than IE. IC is smaller than IE. Okay, then the smallest, being our IB, is measured in microampere, and it is the smallest amongst the 3. So this smallest will help you a lot, maybe while solving and you're seeing that your IC is bigger than your IE. Go back and check your solving. Something is wrong, because in normal sense, it is not meant to be bigger than your IE, and it's not meant to be smaller than your IB. Your IB is not meant to be bigger than any of them. So this little trick will help you avoid a lot of mistake. Now, another relationship that we'll be looking at, still on the current, will be their ratio. The ratio of IC to IB is given to us as what? Beta DC. Or if you choose to represent it in another manner, you say HFE. Okay? Now, if we're to make this expression linear by cross multiplying, we then have the famous equation IC is equal to IDC IB. Now, this expression is quite popular when it comes to BJT. So this is the reason for it. So the ratio of our what? Collector current to our what? Base current is what? Beta DC. Okay? Now, one thing I would like to add before I move on is that this our expression isn't complete actually, because we are neglecting a current that is normally small. So for that reason, it is what's neglected. This current is called leakage current. Leakage current represented with an ICEO. Now, this current is very, very small. It is the current that exists when there is no IB. When there is no IB. So what this means is that when IB is equal to 0, your IC is equal to what? ICE what? O. But this value is so small that is normally neglected. It is so small that is normally what? Neglected. So for that reason, we won't be using it in our own solving unless we are asked to use it. Okay? Now, the next relationship we'll be looking at will be the ratio of IC towards IE. IC towards IE. The ratio of IC to IE is given to us as what? Alpha DC. Alpha what? DC. Okay? Now, it is good for us to note that this value, alpha DC, is not greater than what? 1 or equal to what? 1. The reason why I'm saying this is why we are solving. Maybe you might get a point where you're having 0.995 as your alpha value. Someone would then tell you to approximate to the nearest tenth, and you said to then conclude that the answer is what? 1. It is not accepted. This value can never be what? 1. And the reason for this is because, like we said earlier, IE is small, while IC is smaller. So if we are having a smaller value over a small value, at the end of the day, we'll be having our answer in a decimal form of what? 0 point something. It's not up to 1. So hence, that's the reason for this. This can never be what? 1. And it cannot be more than what? 1. Instead, it is what? Less than what? 1. Okay? Since we now know all this, we can now rewrite our expression to this. IE is equal to what? Using this expression, let's call this equation 1. Using this, we have that IE is equal to, we're going to be substituting, we're going to be replacing this with this. So we'll be having that IE is equal to beta DC IB plus IB. Right? Okay. Now IB is here, IB is here. We can now factor out. We can now factor that out, and we are left with IB This is our common value in the two of them. We're multiplying what? Beta dc plus 1. So that if we open the bracket, we will return back to what? This value. This is also another way to express our what? E. In case if C wasn't given, but beta was given. Another way, or another relationship again will be trying to find is that of what? Beta and what? Alpha. How are they related with what? Each other? Let's try and solve that. Referring back to our initial or our number one equation, which is that IE is equal to IC plus IB. Now, from here, let us divide both sides by what? IC. When we do that, we have IE over IC is equal to IC over IC will definitely give us what? 1 plus IB over what? IC. Remember, what we are trying to get is the relationship between alpha and what? Beta. How are they related to each other? If you have one, can you get the other? We're trying to derive the formula. That is what we're trying to do now. Okay. Now, this expression, if we can recall, that our IC over what? IE was what? Alpha, and our IC over IB was what? Beta. But looking at our equation, they are upside what? Down. So what this means is that this value is equal to 1 over alpha. If our alpha is this value, 1 over it will definitely give us what? This value over here. So this is equal to, you can also try to solve it in case if you're not convinced enough. Try solving 1 divided by all of this. You will see that you end up what? Here. Okay, so we continue. So 1 over alpha is equal to 1 plus, this is the inverse of this. So for that reason, we're going to be writing what? 1 over what? Beta. Okay, now let us make this right hand side to be a proper fraction. Just want to have a common LCM. So with that being said, we can then say that our 1 over alpha is equal to our common LCM. Let's choose it to be beta. 1 divided by beta is beta. Beta times 1, beta. Beta divided by beta, 1. 1 times 1 on top is what? 1. So since 1 over alpha is equal to this, what it simply means, or what it implies, is that alpha will then be, we swapping these values, which will give us what? Beta over beta plus 1. Okay, when you are given beta, you can actually use this expression to get your what? Alpha. Now, what of if you are given alpha and not beta? How can you get your beta? Okay, if our case was that we are giving alpha and not beta, to find the order, and we already know this, simply just make beta from this equation sort of formula. So when we do that, we have that what? When we cross multiply, we have alpha beta plus 1. Alpha times beta plus what? 1 is equal to beta. Then from here, if we open our bracket, we have alpha beta plus alpha is equal to what? Beta. Okay, remember what we're trying to make sort of formula is our what? Beta. So let's take every beta one side and every other value the other side. So when we do that, we have that, let's take this over here. So we have that what? alpha is equal to beta minus alpha beta. Okay, now let's factor out our common value, which is our beta, and we're having that what alpha is equal to beta times 1 minus alpha. So when we open the bracket, we'll return back to this. Okay, now with that being said, dividing both sides by this value, we have that what beta is equal to alpha over 1 minus what alpha. So this is our expression in case beta was given to us to get what alpha. This expression will come in handy at that point. Okay, so let us solve this question under current relationship. Now the question was asked if emitter current is equal to 100 milliampere and base current is equal to 1 milliampere. Find AC and find collector current and alpha DC. Okay, so let's solve. We know that emitter current is equal to IC plus IB. Okay, now we are asked to get what IC. So we will write our equation to be IC, making IC set our formula. IC is equal to IE minus IB. So we cannot impute our values. IC, what is our IE, is equal to our IE, which is 100 milliampere. Since our units are the same, this is how we represent it, minus 1 times what? 10 raised to the power what? Minus 3. But in a case where our SI units or maybe our units were not the same, maybe our base, which is normally given to us in microampere, was given to us in microampere, this won't work. We have to convert each of them separately to their actual ampere value. Okay, but the reason why we are joining them together now is because of what? They are having what? The same SI units. Okay, so from here we then have that IC is equal to 99 milliwatts ampere. This is for IC. Now let's do for our what? Alpha DC. Now our alpha DC, is equal to what? IC over IE. Repeating our formula, we have that what? 99 we'll be having over what? 100. When we divide this, we have our answer to be 0.99. That's our what? Answer. Now you can choose to still add your units times 10 raised to the power what? Minus 3 times 10 raised to the power minus 3. At the end of the day, we will still what? Cancel out. So that's why I didn't add it, because they had the same words units. So at the end of the day, our alpha DC is what? 0.99. Okay, let us try another example. Okay, this one says determine beta DC, emitter current, and alpha DC for a transistor where IB is 50 microampere and IC is 3.65 milliampere. Okay, so let's solve. For us to get our beta DC, our beta DC is given to us as IC over IB. when we input our values, this time around they are having different SI units. So we are definitely going to be including our suffix. So for our IC, we have what? 3.65 times 10 raised to power what? Minus 3, because of our what? Milli, over 50 times 10 raised to power what? Minus 6. So at the end of the whole day, we have our answer to be what? 73. Remember, our alpha and beta don't have SI units, so we just write what? 73. Now for our IE, on the other hand, our IE is equal to IC plus IB. Again, when inputting our values, we're not going to neglect their suffix, which is our times 10 raised to power minus 3 and times 10 raised to power minus 6. We neglected the thing in the first instance because they were the same, but in this case, they are different. So we're going to be having 3.65 times 10 raised to power minus 3 plus 50 times 10 raised to power minus 6. Okay, now from here, when we add up, we have our answer is 3.7 milliampere. So as you can see, our IE, which is the value we just got now, is bigger than our IC and our what? IB. Okay, so the last thing they say we should find is what? Alpha DC. Now, alpha DC is equal to IC over IE. Okay, our IC is what? Now we can neglect the power since they are the same thing this time around. Our IC is times 10 raised to power minus 3, the same thing with our IE. So we can neglect that part. So we can also have 3.65 over 3.7. So at the end of the day, when we divide it, so we have our answer to be 0.986. Okay. Okay. So this is our value for alpha DC. Remember, this value can never be what? 1. Let us try one last example under current relationship. Now this question says a certain transistor has a beta DC of 200 when the base current is 50 microampere. Determine the collector current and also what is alpha DC. So let's solve. All these are simple questions. So the first thing they asked us to find was what? Our collector current. So our IC with the parameters given to us, IB and beta, we have that our IC is equal to what? Beta times what? IB. So the parameters given to us, and we have a formula that says that IC is equal to what? Beta IB. Okay, so when we input our values, we have that what? 200 times 50 times 10 raised to power what? Minus 6. At the end of the day, we have that our answer is what? 10 milliampere. Okay, 10 milliampere. So this is for what? Our collector current. Now they say we should also find alpha DC. Now we can go through the process of first of all looking for emitter, since we know it is IC over what? IE. So we can follow the procedure of first of all finding our IE, then inputting into this formula to get our DC. But since we already have our what beta, there's already a shorter formula that we already know, which is that beta alpha DC is equal to beta over what? Beta plus 1. So this is the one we'll be making use of. Now inputting our values, we then have that what? 200 over 200 plus 1. When we input this in the calculator, we have our answer to be what? 0.995. Remember again that your alpha DC can never be what? 1. So hence the reason why we do not approximate to the nearest tenths. Okay, so that's all for this video. Please like, share, and comment. Share this with your friends and loved ones and classmates who are also treating electrical electronics or is having BJT popping up in their semester scheme. See you guys in the next video. Goodbye.